All right, it's 3:30. Welcome to TSVWG. I am Martin Duke. We are unable to correct the typos on the title slide for various technical reasons, so both my name and the G in Bangkok are missing. Martin Zeman is a little under the weather, so he may be joining us remotely depending on his state at that exact moment.
So I guess the first thing to do, I'm Gori again, the first thing to do is to announce Martin Duke will be joining us now for forever as the TSVWG chair until we let him go. Martin Zeman's taken over a chair position in another group and will not be continuing as a chair after this meeting. And alas, after many years, I'm also not going to be continuing as a chair as I take an AD position, hopefully this evening. So at the moment, it's Martin Duke. After the new AD incoming is in position, we'll be looking for a new chair to work with Martin.
Gori, I'm just happy you're not going very far because your institutional knowledge we can't afford to lose. Okay, I'm supposed to pass on some additional news that we neglected to discuss in document status last time. Number one, the UDP options draft is with the RFC editor after much, 15 years of toil. The DPLP MTUD draft. I love that acronym. You guys have a knack for naming. There's a little kerfuffle in the ISU balloting process about compression effects, but it did not change the protocol. And the end state of that was it is going to progress to the RFC editor without that text. So if any of you are following that and taking interest in it, that is the resolution to that. We have many drafts today. We're unlikely to get to all of them, but that'll come up in the agenda.
What did I miss? There was clapping going on. What did I miss? I just joined this room.
I think Zahid might be fishing for a thank you, which is richly deserved. Zahid, you have obviously yes. I mean, I think more than most people appreciate what you've done as area director, and the labor and the effort associated with that. And of course, Gori's dealt with many area directors in his time, and yeah. So thank you for what you've done. I was going to save that for the end, but we can do it now. So thank you, Zahid. All right, moving on. Let me keep going. Yeah, this is the note well. You were probably here 2 days ago when we last did this, but the note well, which you can read, talks about the intellectual property implications of you being here. So if you're not familiar with it, please take a look at it. It does also talk about the code of conduct, behavior. If there's any harassment issues, you can come to us chairs, and we will be happy either now or offline. We'll do our best to resolve the situation. If you find us to be untrustworthy gentlemen, which you are entitled to do, our area director is right there. Our future area director is sitting to my left, which I guess doesn't work great in those terms, though. But nevertheless, there are a number of, and there's multiple authority figures in the IETF you can go to if you have concerns about harassment and other sorts of misconduct. And we encourage you to come to us as a first step if that is amenable to you. Okay, go for it.
Okay, so this is our agenda for the speed version of TSVWG. These are all short presentations. We're going to start with a recap on the position of the DTLS and SCTP by my working group chair to the right. And then we're going to look through a series of drafts. We may get our way all the way to the end. If we don't, then please take a look at this list of drafts. We recently added Greg White's to the if time permits on stamp for DSCP and ECN. They are core things in this working group, so please have a look at that stamp spec within IPPM, just to see if that's useful, and have a look at all these other things. Now over to Martin.
I regret to say you've already missed the IPPM meeting for this week, so you'll just have to. Yeah, it has already been presented, right? So you can't go to IPPM this week and hear about it, but you can read about it, you can watch the proceedings, etc. And obviously on the GitHub, I assume there's a GitHub. Greg will happily take your comments. Okay, from ECN enthusiasts. All right, so I guess first supposed to talk about the SCTP situation. I think most of you witnessed what happened 2 days ago. It was fine. There was no misbehavior or misconduct, but we didn't really reach a consensus. So we've communicated with some of the stakeholders, and we have a way forward. First of all, we're going to reconvene the design team, which consists of the same people, and ask them to please, pretty please, reach agreement on this and find a mutually agreeable solution. However, we're setting a pretty firm deadline of the Madrid meeting. And if there's still no agreement in the Madrid meeting, then we will, then a chair, which I think defaults to me given the status of things. So I'll just personalize it. I will create a slide that expresses the pros and cons of various solutions, basically options 2, 3, and 4 for Magnus's presentation on Monday, and we will have essentially, and having presented those technical that list of trade-offs as neutrally as I can, then we will have a series of shows of hands to see if we have anything like a rough consensus to get from those 3 options to 1. If in the judgment of whoever's the chair at that time, we have a rough consensus, then great, we're going to move forward. If we don't, then we will basically declare bankruptcy on this matter. We will notify 3GPP that we cannot reach consensus on a solution, and we'll move on with our lives. So the happy solution here is the design team comes up with a mutually agreeable compromise. The second best choice is that we as a community are able to reach rough consensus on a solution. And the third outcome is we give up. Okay, does anyone have questions or comments about that plan of attack?
Yeah, as ever, if you think you are a stakeholder in this, please let us know as chairs. Let's let Martin know, and please join the activity. So this is not meant to be a private design team, it's just a design team to make rapid progress. So please let us know if you'd like to join that, or if you're a stakeholder in this that feel that there's something important to be considered.
And I think never mind. There's no slide for the scribe, but I do want to thank Marcus Eilar for being our scribe today. Thank you for agreeing promptly and quickly before, so we didn't have to spend time on it in the agenda. Is this did we not talk about this liaison statement? Okay, that's done. Lovely. Okay, in that case, our first presenter is Mohit Taliani about FlowQPy.
So, Chairs, Eddie interrupt. I have something still to do as a Eddie. So
okay.
There's a mail from Gauri, who is the author of this DPLPP QDP option, right? The question he asked, he discussed something and you have a text proposal, but I'm not sure where to put those text, and I didn't say anything on the mailing list. So I mean, I'm gonna approve this one without this additional text. If anybody objects to that, or now is the right time to object that one.
And Gauri, strictly with 0 hats, is happy with that outcome. I think that's fine.
Hello, everyone. I'm Mohit. I'll be talking about the internet draft, which I submitted during the Dublin IETF during 121. It's called FlowQPy, in short, FQPy, which is a hybrid packet scheduler and active queue management algorithm. Overview of the draft is that it combines 2 things together. It combines flow queuing and the Pi algorithm. It's pretty similar to how FQCodal combines the flow queuing with the Codal algorithm. And the functioning of FQ is pretty similar to how it has been already described in the FQCodal RFC, which is RFC 8290, wherein the incoming packets are hashed into buckets, and then we have each queue, and each queue runs its own Pi instance. And of course, when there is a DQ, we have a DRR-based packet scheduler as described in RFC 8290, which we have also listed in FQPy draft. And the functioning of Pi specifically is similar to its RFC, experimental RFC, which is RFC 8033. There's only one modification that we have done as per the recommendations of RFC 8033. RFC 8033 provides two ways by which we can calculate queue delay in pi. The first approach that RFC 8033 provides is using Little's law, which uses the average departure rate estimation. And the second option that they provide to calculate queue delay is using timestamps. Based on our work on pi and also on FQPi, we realized that actually timestamps are a better way to calculate the queue delay. So we have just recommended that FQPi should use the timestamps as a primary mechanism to calculate queue delay. But we also suggest that the Little's law can be an optional way to calculate queue delay, as it has been already provided in RFC 8033. Presently, there are 3 implementations available for FQPi. The first implementation is Linux. It's supported in a few distros. We also have implementation in FreeBSD, and there's an also implementation available in the Network Simulator 3. So the current status of FQPi among the other queue management algorithms that have been already standardized at IETF stands as shown in this table. And I'd like to thank Michael for suggesting this table. Actually, I had put up this particular draft in the mailing list, and he replied in support of this with this table. So I just took this table from the mailing list, where we can see that Codel, FQ Codel, Pi, FQPi, all of them have Linux and FreeBSD implementation. But so long as the specification is concerned, we have all the other 3 available in the form of specs. All of them are experimental RFCs, whereas we don't have one for FQPi at this point of time. And yes, at this point, so we also have performed some experiments with FQPi over this hackathon that we had. But before I go there, I would like to ask chairs whether the group is interested in this work, and then maybe take the next slides if that's the case.
Yeah, I mean, it's a good question. Is this working group interested in developing a spec for FQPi? We have specs for the other congestion controls, but not for this combination. Is this a useful activity? Is this a useful spec? Think about it. You come to the mic if you like, but I'd also like to run a poll if we can. Can we, co-chair, run a poll? And just ask, who has read this, first of all? Who has read the FQPi spec? It's quite short. If you've read it, please can you indicate so I can get some feeling as to how many people are able to answer questions about it? Just hold this poll for a minute. Okay, so people are reading it. While we're doing that, we're going to leave the poll open just to collect the answers, and then we're going to do a new poll and ask who thinks that this is a useful piece of information for the IETF to work upon. We're not doing an adoption call, we're just trying to sense the room, and we will perhaps run an adoption call later, but we just want to know who thinks that this is useful. So we see 10 people in the poll saying yes, they've read it. Who thinks that this is a useful area to do a new specification for this working group? If you think so, well, let's run a poll. Yep, run a poll for that. Not adoption, but just thinks this is a useful topic for which to develop a spec. Useful thing to work upon. Yep, this topic. Because we got the poll right, you can still respond to this poll even if you haven't read it, because you believe you understand what it is about, so that's fine. Okay, you've generated some interest, and I think that's useful input to us. If you want to use the last couple of minutes just to show your results, I'd encourage you to do so, but remember the time's limited.
Oh yeah, sure, thank you. Over this hackathon on Saturday and Sunday, yep, Martin's question.
Martin Duke, Google, as an individual, just on the subject of applicability, I do think the queuing may fall in the charter of CCWG. So it's up to the ADs, present and future, to decide where it goes. And it doesn't mean we can't talk about it for 5 more minutes today, but in terms of where it actually lands, maybe not here.
Jahed, as a Eddie. Martin, thanks for picking up, because exactly that was my reflection. I think you should really talk with CCWG chairs, because this the CCWG has congestion control and queuing mechanism in the charter, and I personally would like to see like all these kind of actually things happening in CCWG rather than here. Yep.
Sure. So thank you. So we spent some time over this hackathon on performing some results. Before coming to this hackathon, also, we have actually performed some experimental results. So in the additional slides, we did some testing using the Flend tool, which is actually used for the testing the buffer bloat situations. And we were supported by Quantum Networks. They provided us their access points. So thanks to them for giving us the equipment. Where we tested this in our campus network at our university by using the Flend test. Particularly, we chose two tests of Flend. One is we used the real-time response under load, and the second one was the TCP end down tests, particularly checking on the last link where the buffer bloat happens. And we had some interesting results. We always have been looking at FQCodal and FQPy together. And this is the ellipsis plot that we got from the R-rule test that we performed on the campus network. We also performed a test for TCP end down with a lot of TCP flows in the download direction, starting from 50 flows to all the way to 300 flows. And again, we could see there were very interesting plots where there is quite some difference between the throughput that we observed. But during the hackathon, we actually worked on CCPerf, which is a small framework built on top of NS3. And NS3 has implementations of FQCodal as well as FQPy. So with the team of my students, we performed all these tests. But in the interest of time, I will just present one which we found interesting, which was particularly response to the pulse wave. And this is a plot that we got for 3 parameters. The first one is in-flight data. The second one is the throughput. And the third one is the smooth RTT. The dashed lines show the minimum RTT that we expect. This throughput values that you see here at the top, these are the bandwidths this is a bandwidth value that we fluctuate. So we have 32 Mbps, then we reduce the bandwidth to 16 Mbps, and we keep doing that. And we found some observations with FQCodal where we could see that for some reason, whenever the bandwidth actually increases to 32 Mbps, we don't see FQCodal utilizing that throughput, and we are still investigating as to what is the issue that we found it. When we looked at FQPy, we could see that FQPy had a similar behavior in the first phase, but due to the Pi controller's mechanism of correcting the errors, it actually goes up next time and starts utilizing the proper throughput. But yes, we are still doing this test, and these are some very preliminary results that we actually got during the hackathon. We had some students here. We utilized time in actually running these tests. That's it. Thank you.
Comments or questions? Go ahead, Richard.
Richard Scheffenegger. As a former AQM working group chair, I really like this work. It really feels like we have left the ball back when the working group was stopped, not having FQPy as well. Thanks.
Thank you.
Christian, please be brief.
Yeah. Have you considered L4S? I mean, have you considered applying some kind of L4S-like discipline instead of merely marking the ECN packets are lost when they are lost?
Not in the experiments that we have conducted so far, but we have L4S support in the FQPy implementation in NS3. So we'll look forward to do some testing with that. We do have a working model of FQPy with L4S in NS3.
That's great. Thank you.
Next. All right, that's all the time we have. Thank you, Mohit.
Perfect. Thank you.
Next up is Martin Zeman, who I see is remote. Oh, no, he's not. Oh, he made it. If I can find him.
Yes, they don't follow the name scheme. I uploaded them.
Did you do it to the other session? Oh, great, thank you.
Hello. Christian is already in the queue.
Now you have control.
Okay. Well, this draft came out of a discussion we had in Dublin when we were discussing Martin Duke's draft about ECN socket options. And I remarked it would be nice to have the same thing for UDP fragmentation, and I suggested to add it to the draft. And Martin really doesn't like scope creep. I was told to write my own document. So here we are. So what do I want to do? I want to control how UDP packets are fragmented in the network. In IPv4, any router on the path can split up a packet and send 2 IP fragments that are then reassembled on the receiver side. In IPv6, this doesn't exist anymore, but IPv6 still has a similar problem because the kernel of the sender, or the kernel of the host, might fragment an IPv6 packet. And you really don't want this if your application is doing a path MTU discovery. You want to send the largest packet that doesn't get fragmented to the network. So there's, for IPv4, there's a bit in the IPv4 header that tells routers to not fragment a packet, but to drop it instead and to send an ICMP to large message. And for IPv6, there's no signaling on the wire. You can tell the kernel to not do any fragmentation. So what the draft does is it summarizes how we do this on different operating systems. And very frustratingly, as you can see in this table, every operating system handles this differently. The socket option has a different name on every system, and for IPv4 and for IPv6. It gets even more frustrating when you look at dual stack sockets, because the behavior completely diverges. On Linux, you can set both options independently. On macOS, it was not possible to set the don't fragment bit at all on a dual stack socket before the current version of macOS. Fortunately, they fixed that, and now you need to use the IPv6 don't fragment option to turn off fragmentation for IPv4. Makes total sense, right? And on Windows, it's different again. You need to use the IPv4 don't fragment option. So that's a lot of fun. And I did all of this in my quick stack, and I thought I'd just look at the logic I implemented there and put it into the draft. And we double-checked this. I double-checked this with my co-author, Max Inton from Mozilla, and he checked what they have implemented for the Neko quick stack, and it matches. The draft also mentions an attack that's possible. Because on Linux, as we can see on the previous slide, there's 2 options you can set the socket option to, 2 values you can set the socket option to. It's PMTU discovery probe or PMTU discovery do. And what they both do is they prevent fragmentation on the sender side. They set the don't fragment bit, so no difference here. But the difference is how the kernel reacts to ICMP packets. If you're using the, oh no, I messed this up. It is exactly the other way around as it's written on the slide. I'm sorry for that. So if you're setting the do option, the kernel will process ICMP packets. And if you are then trying to send a packet that's larger than the size that was in the ICMP to large packet, then will give you an error on your send message call. If you're using the probe option, the kernel just ignores all ICMP packets. There's an option to get them into user space, but the kernel will just let you send larger packets. So the attack is now if you have a quick stack, let's say, and an attacker injects an ICMP packet, the attacker might be able to convince the kernel that the path MTU is smaller than 1200 bytes, which is the minimum the minimum packet size required for QUIC, and therefore make it impossible to use QUIC on the path, even though, of course, the path does support larger MTUs. And I actually had this bug in my QUIC stack, and I went through a disclosure process to get this fixed. So I guess it's, at least for me, it would have been helpful to have this documented somewhere. And the draft talks about that as well. Yeah, that's all that that this document aims to do. Also, don't want any scope creep, so please don't suggest adding any other socket options. Let's focus on UDP fragmentation here. Lorenzo?
Why bother documenting the behavior of AFINET and AFINET 6 in the interest of lack of scope creep? Just why not just use dual stack sockets all the time? Just making it harder for the programmer to get all of this stuff right. I mean, is there any reason not to use dual stack sockets everywhere?
I'm not sure if I understand the question.
You had like this 3x3 matrix, right? Why don't you delete the IPv4 and IPv6 rows? Like, why use those socket types at all? The only thing you can do with them is make things harder for yourself or anyone who's coding something, some networking code, right?
Are you asking why people are using IPv4 only sockets?
Yes. Why document? Why instead of saying like, you know, oh, if you're using IPv4 socket, do this. Why don't you say, well, we've recommended to use dual stack sockets? It's a lot harder to code things with single stack sockets, I found.
I guess there are use cases where you only want a single stack socket, and people still do that.
We know what they are. Well, let's not just cargo cult them, like, you know, perpetuate them because we know that there's code that uses them, right?
Do we have any recommendation anywhere that you should use dual stack sockets and you should avoid single stack sockets?
You should write a new document. No, I don't know. I don't know. I mean, I think the traditional answer to that would be the IETF doesn't do API recommendations. But then we end up with stuff like this where we have to say, well, somebody might be using it, so we have to document it. So yeah, I would advise, you know, pragmatically, I think in this draft, you'll probably say, well, you know, you should probably like use, by the way, you know, Martin had a similar document in the other session, right? Maybe you should say, don't use single stack sockets. I was aware of one use case under Linux where you couldn't do, you couldn't send a ping packet. This Linux has a special ping socket. You couldn't use a dual stack socket to send a ping packet. But UDP and TCP should just work, so.
Maybe I can ask Martin if he has thought about something like this for his draft.
So like as the guy who I guess made this initial like template decision on how these informational drafts should go, I was trying not to be too editorial in it and just sort of describe how to do these things. There is a v6 only option, like a sock hop that you can set. So someone thought it was a great idea. And I'm not trying to second guess that on why they might have done that. I was just trying to write down how you do ECN. I think to speak for the other Martin here for a minute, like, I mean, he probably has the same attitude.
Okay, and we have Michael Tuxen in the queue.
Yeah, so I guess some people prefer IPv6 only and IPv4 sockets because when they get presented addresses, they know which format they are. If you use a dual stack socket, you wouldn't get IPv4 addresses, you would get always an IPv6 address, which then is a mapped address. So as far as I know, that is something people prefer than using an IPv4 socket, and they get the IPv4 address as they expect them.
Okay, thank you for doing this talk. I don't see more questions. I would like to ask the room who has read this so we get a sense of where we're up to in the process. So we're just going to start a poll as to have you read the MTU sockets draft? I'll leave that for a moment. And what are your plans for this draft? Are you going to continue working on it?
Would be nice if it could be adopted by the working group.
Okay. It might depend upon how it evolves. So let's see what. At the moment, we see some people have read it, and probably we'd encourage more people to read this. And now you've presented, and give feedback to the list to help encourage the direction of this document. So thank you for the talk.
Thank you.
So we record 5 in the notes, please, for reading this particular version. Who's next is Stuart. No,
Thank you. We may have much of the same audience here as Quick, so I will try not to bore people. 14 years ago, I was investigating why screen sharing was so sluggish. It turned out not to be lack of bandwidth. It turned out not to be buffer bloat in the network. It turned out to be buffer bloat on the source device. Some frames were in flight to keep the bandwidth delay product full. That's blue, that's good. But a whole bunch of other frames were just sitting in RAM waiting for their turn to go out. There was a 2-second backlog, and that's not good. We fixed it by giving the application control to not send data prematurely before the transport protocol was ready to send it. So that's great. So in that case, why am I here? I'm here because this problem has resurfaced recently in some of the Linux servers that Apple runs. And turns out that just fixing it on iOS was not enough. So that was our mistake. And now I'm here to talk to the whole IETF community. We would like to see similar, consistent, low latency performance on different platforms. And of course, in 2011, Quick didn't exist. I think Quick would benefit from this just as much as TCP. So why is this important? In the 1980s, we had ideological disagreements between the net heads and the bell heads. And the bell heads said that a packet switch network could never do telephony well. They said that an adaptive, best effort datagram network would never keep latency under control. And the bell heads were wrong about a lot of things, but they were kind of right about that. We spent 30 years in the IETF with all kinds of efforts on diff-serve and RSVP and traffic classes and priorities, and we still haven't really solved the latency problem. So, what am I asking for? We have a draft that describes the problem. It's not too long, and hopefully it's quite readable, so my request is please take a look. If you find what it says convincing, please join our mailing list. For now, we have a non-working group mailing list until we decide what is the right home for this in the IETF. Please send us feedback. If you have an implementation that doesn't have these problems, tell us how you did it. So please give feedback and we'll decide next steps in Madrid in July.
Lorenzo, are you in the queue for this? Yes.
Thank you for, bringing this problem to attention again. I think it's obviously, a lot of it is a lot of this stuff is, as you point out, self-inflicted. One thing to think about that may make it a bit difficult is some networks where, in order to, so on cellular modems, a lot of the time the modem would only apply for a grant from the network if it's got packets that it needs to send. And so that's one of the reasons why people like to use BIC, because it hits the network as hard as it can, and it fills up the modem, and then the modem send buffers, and then the modem asks for more grants for the network, and things end up going faster. So I'm sure Wi-Fi has similar problems when it's applying for TX-ops, probably. So that's something could be interesting. It's going to be interesting to work on, partly because that stuff is not specified here at the IETF. We don't have APIs for it or anything. but it's definitely an interesting problem to work on. Thank you.
Yaroslav?
Thank you for bringing that up, Lorenzo. There is a little bit of wording in the draft right now about that relating to Wi-Fi and aggregation. We should definitely add something that relates to cellular. And I think the pattern that you're describing there is something we have been doing ever since I was a student, my entire career. We act like there's a scarcity of bandwidth, and the only thing that matters is getting the maximum possible throughput, no matter what the consequences, right? No matter how bad the usability is, no matter how terrible the user experience is, if iPerf has the biggest number, that's all we care about. And in the days of dial-up modems, when we went from 300 baud to 1200 baud, and then if you were really lucky, you had a 56K modem, yeah, we were really starved for bandwidth. And then after modems, we went DSL, we went megabit, 10 megabit, 100 megabit, gigabit. I'm now getting bombarded with offers trying to sell me 2 gigabits and 10 gigabits to the house. At some point, we passed the point where scarcity of bandwidth was no longer the problem, but we couldn't mentally adjust, and we've been trying to solve the problems of the 1980s in 2025.
Yeah, I just wanted to support this initiative. I think it applies not only to operating system sockets and buffers on network interface cards, but also to things such as buffers on mask or other VPN technology encapsulators, because in certain cases you want to buffer as much as possible and get as much bandwidth as possible. In others, you want to get things quick and reactive. So it's really multifaceted, and you could have hierarchical buffers that you need to reason with. So having a common language, common set of APIs would be extraordinarily helpful in many applications.
Yeah, thank you for saying that. I'll add a note to the draft as well about what you said about VPNs and similar tunnels. I think one of the things that's going on here is when buffer bloat in the network was so bad, it hid all of the other problems. Now that we're actually fixing buffer bloat in the network, it's starting to expose where the bloated buffers exist in other places. It's a little bit depressing, but on the other hand, I feel like we can identify them and fix them, and it's going to be a transformational. It'll be like going from a spinning hard disk to an SSD in terms of the responsiveness of the network we could make in a few years' time.
Christian?
Yeah, that's a great idea, Stuart. I like this thing. But 2 points. First, GSO. I mean, the performance of things that quick depend a lot on doing GSO and sending trains of packets. So I assume that whatever you implement there in terms of feedback provides way of actually sending n packets at a time.
Yes, I agree 100%. I don't want this message to be that batching is bad and we should just send one packet at a time. Wi-Fi uses aggregation, cellular needs grants, even at high speeds on Ethernet, doing some kind of batching instead of one at a time is beneficial. So that is the challenge we have, is to do the right amount of batching. And I was talking to somebody earlier this week, I forget who, sorry. You can imagine 2 graphs overlaid where you've got throughput and you've got latency. And there's kind of a sweet spot in the middle where you're getting at least 90% of the theoretical maximum throughput, and you've got good latency. And if we measure throughput and working latency and tune for that middle ground, we can do both really well. Right now, we haven't done that, and we're way out on one end of the spectrum trying to get 99.9 something % of the theoretical maximum bandwidth without any regard for the latency. So I'm not arguing to go too far the other way. I'm arguing that we find right middle ground where we balance throughput and latency in a more sane way.
And the other point is something you presented in Quick about the promise type of architecture that many Quick stack use. And a flip side of those promise stack architecture is that if the Quick stack commits to sending a packet, and the application prepares it, and then the socket API says, no, you should not have that. I have too much stuff in my buffer. That's a real bummer. Basically, there's nothing to do in the quick stack at that point, but just drop the packet. And that's...
I may have misunderstood what you said there. So let me try to answer it and you tell me if I got it wrong.
Yeah.
What we talked about with what we did 14 years ago with TCP not sent low watermark is not about socket refusing to take the data because the socket has decided it's too much. It's the other way around. The socket is willing to take as much data as the application wants to write. That is still the application's decision. The difference is that the socket stops being a bottomless black hole of packets where you have no visibility once you throw a packet into it, what happened. So it's a richer communication to the application, which is you can write now if you want to, but I'm just warning you, it's not going anywhere. It's just going to sit on this machine waiting for the congestion controller to decide it's ready to go out. With that knowledge, if you still want to write, you can. But if you'd rather hold off grabbing that screen frame for a few milliseconds, that's your choice. And it's about giving the application the information it needs to be intelligent.
Okay, I'll have to ask you to take the rest of this offline.
Yeah.
We're going to move on to, we're going to have to move on to Daniel.
Hi, can you hear me?
Yes, I'm going to hand you
Okay,
control of the slides when I find you in the list. Oh, there you are. Go for it.
Okay, hi. So hi everyone. So what I'm presenting is some work we're doing in IPsec-ME. And what we are looking at is a transport feedback if we are handling the MTU and fragmentation well, or if there is anything we should change, or I would say any feedback is welcome. So I'm trying to do slide 2. Okay, right. So what is the situation we're dealing with? We do have a source sending an IP packet. This IP packet is being encapsulated by this ingress node, security gateway. That encapsulated packet is being transported into an IPv4 network to a security egress node. We're using IPv4 and we have a DF set to 0. Which means that some mid-tunnel fragmentation can happen. So when this fragmentation is happening, the egress node is receiving fragments, and what we're doing is that we are sending an IGV2 message to the egress node, and we provide the information of the IP version of the fragmented packet, as well as the fragment length, which is the length of the initial fragment. The expectation is that when the ingress node receives this information, it can take some actions to propagate the MTU. So it can basically reduce the MTU to the fragment length indicating that packet, and tells the source node to decrease this MTU, to adapt the MTU. So we do have another version of this protocol, is that when the egress node receives the fragmented packets, it might reassemble them, but this reassembled IPsec packet might not be preceded by this egress node. In which case, I mean, the reason is, I mean, the reassembled packet, it might be larger than the effective MTU to receive. In that case, we do send an additional notification to the security gateway, the egress node, we provide the link MTU and the effective MTU to receive. So that's another variant of it. And I mean, optionally, we can also send through the IPsec tunnel an ICMP packet to big message. But so we can use different channels for that. So let me tell you why we. I mean, one of the. I mean, before you suggest why don't we use DF set to 1? I mean, the reason we can't send packets, IPv4 packets with the DFs sent to 1 is the first reason is some of the routers in path do not even send any notification when fragmentation is happening. Another reason is that a security gateway are usually placed behind firewalls, so they don't even receive the ICMP packets. And this is a transit network, so it's not really a network that we have control on. And the other reason is that even though you might send ICMP packets, when you use ESP over UDP, you don't have sufficient information to identify the connection that causes issues. So because the SPI, which is the security protocol index, is not provided by the ICMP packet. So what we are looking for feedbacks on, the question we're wondering is that do you see any negative impacts? And I mean, the way we're doing it, do you think there are anything wrong we're doing? Any negative impacts? And the second question is, are we doing it the right way, or should we use any existing mechanisms to prevent fragmentation? So that's basically the question we're asking, and we'd like feedbacks so we can move this draft forward into IPsec-ME.
We could take questions. And I'll give you the. Have you finished your talk? Yes?
Yeah, I can take a question. Yeah, sure.
Okay. So my first question is, what's the intention for the draft? Is this intending to proceed in IPsec-ME? Is currently an individual draft? Is that the current status?
Yeah. Yeah, so we discussed that in IPsec-ME. I mean, I think IPsec-ME is the right place. But we didn't want to take any decisions regarding MTU without having the MTU folks acknowledging that we can do that. We are not breaking anything. It's okay to do it this way.
So I guess that's a question to the room. Is anybody wishing to comment upon the draft? We could use our mailing list to discuss this item briefly and see if anybody does have feedback, please send it to the authors and use the list, and then let's return it to IPsec-ME.
Yeah, those of you who are MTU enthusiasts, like having a look, I mean, I know this is like a security things that you may have like turned off your brain or went to your laptop, but like this is the place for MTU. So like, please lend your knowledge. Thank you, Daniel.
Thank you.
All right, Christoph, we have time. Are you out there? Great. Which one is it?
So this is another draft that was brought here for comment because this is a place where we hopefully have understanding of DSCPs and PHPs and other language concerning the use of diffserv. And this is a document that talks about these. So go ahead and tell us about it and why you're here.
Thank you very much. So I am presenting this draft on behalf of my co-authors, so Luis and Ivan presented here. We presented already this draft back in Montreal to TIS group because it's somehow related to the slicing as what TIS group is discussing. But I would like to present here as well. I put only very short extract from the presentation that we did in Montreal because we got only 5 minutes here. Essentially, this draft is the informational draft. So we are not trying to standardize anything. So standardize, I don't know, the DSCP values, and standardize the mappings between 5QA and DSCP and so on. It's pure informational draft focusing on the methodology. So what can we do with 5QAs? So in 5QAs, if we know in 5G QAs, we have like 85 QAs, so 5G quality of service identifiers. The question is how we take these identifiers eventually to the transport network, to the IP network, MPLS network, and how we provide some differentiated behavior for these 5 QIs. So the methodology that we propose is that we group these many 5 QAs in certain limited number of groups. The reason is we group in the limited number of groups because we have limited number of resources in the routers. Like we have maybe 4 queues, maybe we have 8 queues, depending on the hardware capabilities. So there's limited resources that we are available. So we are grouping multiple 5 QIs. So proposal is the first group, there's an example again, informational draft. So the first group is that, let's say, low latency 5 QIs I grouped in the group number 1. Then medium latency 5 QIs I group to group number 2. And then remaining GBR, so guaranteed bitrate 5 QIs I group to group number 3. And whatever is left is group number 4. So we have from multiple 5 QIs. Eventually we come to the 4 groups in an example here. And then we are mapping these groups to the resources that we have on the router. So here's example with the 8 queues, but of course there could be example of with the 4 queues, and we've got already some comments on the main link list that some routers maybe they don't have so many resources, so only 4 queues and so on. So we are mapping as an example of mapping of these groups to the resources that we have available. Of course, the high priority groups like group number 1 is mapped to some queue that is constructed in such a way that provides better priority comparing to the group number 2, 3, and 4. And of course, we have additional traffic in the network, typically not only mobile traffic that we have here in an example, but we have some network control traffic that we need to handle, I don't know, BFD protocols. Maybe if this is the frontal part of the network that serves as well the frontal part of the traffic, which is ECPRI. So we put that in the example. Again, this is not standard track, it's informational track, what methodology to use to handle 5 QIs. And this is all what I have. So as I mentioned, we prepared only 2 slides because we've got only 5 minutes. We of course expect you to provide the comments. We already start to receive some comments so that we can progress in this work. Thank you.
Rüdiger.
Thanks. I like your work. As I have been writing, I'd really appreciate if you were mentioning L4S, as this is pretty much doing what you describe. You have different 5 QIs, you have a mapping of classifiers by IP, and you change a bit setting on IP level. This is a huge step in cooperation of 3 GPP and IETF on quality of service. You do not need to go to details, just mention it and put it out of scope if you'd like to, but I'd really appreciate if you were doing that. Thank you.
Okay, thank you. So at the moment we are concentrating on the DSCP bits, which is the 6 bits from the TOS, yes, and ECN bits we are not taking into account in the current version of the draft, so we're looking for the ECN bits and L4S as well.
Just, you can put it out of scope, I don't care.
Right, understand, yes.
All right, if that's it, thank you very much, Christoph. Mr. White, can you use 5 minutes instructively? Sounds like it.
Right, as was mentioned at the outset of the meeting in the agenda, this is a draft that was presented in IPPM, proposes, the name of the draft is there, proposes a extension to the stamp measurement protocol to enable bidirectional measurements of ECN. It could be used for detecting ECN manipulation in each direction, bleaching or congestion marking, as well as performing measurements of the performance of the path, which could depend on the ECN value. There is an existing extension in the STAMP protocol that defines the ability to do this bidirectionally for DSCP, but it only allows really the outbound ECN measurement, doesn't allow the return path. And I'll skip ahead. So pretty simple. Effectively, the STAMP session sender can send out a packet with this TOV, provides an instruction to the session reflector that in its reflected packet, the header should use a particular DSCP and ECN value, and then also has a spot for that reflector to include what it received in the IP header of the inbound packet that's it's reflecting. The discussion in IPPM was, hey, we've seen this before. This was proposed some time ago for an older protocol called TWAMP, and it was shot down by people in the transport working group because it is a way to instruct a device, well, it assumes a device is going to send packets with a certain ECN marking, and there are certain rules in existing RFCs around which values a host can use, which values a router can use, and if you're letting a measurement system in any value at once, then you're violating those written rules. That's my understanding of the previous discussion. I was not involved in that. So question for the working group is that really a concern? Do we not want to have standardized ways to do measurement? Or how do we handle that? So it's like Corey's coming to the queue.
Yeah, I'll talk from down here. That's more fun. Is this rate limited? I mean, there's a kind of contract with ECT that you're congestion controlled, and presumably you're not. And how does that work?
I am unfortunately not a STAMP expert. STAMP has some mechanisms to prevent abuse. For example, a session reflector can operate in a authenticated mode where it only responds to trusted session senders.
STAMP experts coming up.
Yeah. And I'll defer to others who may be more expert. Thank you.
Yes, thank you. That's a very good question. So effectively, there is none control on the rate. So basically, yes, the session sender might send as many packets as possible. Even more so, we are working on extension that, so again, there might be something that needs to be very restrictive in the security consideration of this mechanism, because one of the documents that we're advancing, and it's been presented earlier this week, it's for the rate measurement. What it essentially does is it may generate multiple reflected packets in response to a single stamped packet sent by session sender. So then one can imagine that if that mechanism combined with this, so then ECN being sent in the reflected packet to non-zero might cause some interesting events. And then on top of that, actually STAMP might be used in a multicast environment. So then you have multiple packets being reflected by all your leaves in the distribution thing. So again, I understand that this monitoring might be interesting, but as was really discussed in the TWAMP, there should be very limiting, not limiting, very strict security considerations.
Corey, if that answers, if you have, please be brief.
Yeah, I think somehow we have to think seriously whether the ECN loop can be closed with those CE packets influencing the stamp sender, because otherwise it seems really crazy to say I can choose EF traffic with particular ECN markings at any rate I choose. So I have a few things to think about there.
right, thank you.
Rudiger.
Thanks. There is a UDP speed test where you could implement such a functionality if you would like to test it with load. If it's just about the marking, I think a stamp is fine. Then you should work with a low rate and just control settings, whether settings are changed. But if you want to control functionality, you should better go to UDP speed test, as it is having a feedback control and a rate control. Thank you.
All right, we'll continue the discussion on the list. Thank you.
Thank you, Greg. Well, we got through the whole agenda. Thank you, everyone. This is the end of an era. Thank you, Gori. I mean, you know, we always thank outgoing people, but nobody remembers when you weren't TSVWG chair, I think. Maybe somebody does out there, certainly not me. So, wow, what a record of service. And again, you're not going far, so that's great. And thank you, everyone, for coming. We will see you again in Madrid. And thanks to Marcus for keeping notes.